Good morning, everybody. So obviously I'm not there today. The baby's sick, so I should be back on block day. But today what I need you to do is just to go through this video. I need you to really go through it as if I were there. Really try your best on this so that you can earn your points on this assignment. So originally our agenda, we were supposed to do the distance formula today and then project work time, but since I'm not there, we will do the distance formula, but no project work time. Instead, in Google Classroom, you will find an Edpuzzle video and some practice using the distance formula. Just a couple of reminders that your Pythagorean theorem project is due this Friday, the 22nd, during class. So please make sure you're working on that. We will have time in class on block day to work on it. But that's it. So if you're not done with it by block day, then you will have to take it home to finish it. And also this Thursday and Friday, you will have a test on the Pythagorean theorem and distance formula. Okay, so let's get into today's activity. So what we're going to do is we're going to take the right triangles that we've been working with and we're putting them on the coordinate plane. By doing that, we're able to find the distance formula, which is derived from the Pythagorean theorem. So if you put on your thinking hats, you should be able to get to the distance formula. It's essentially the same thing as Pythagorean. It looks a little bit more daunting, but if you really think about it, it makes sense. So let's go ahead and get into it. All right, so for this activity, here are the directions. You're going to complete this discovery lab during class, and hopefully by the end of it, you should arrive at the distance formula. Do not move ahead of Mrs. Zui. So since I'm not there, I really need you, when I say pause the video here and think about this question, I really need you to do that rather than just moving forward, because I want you to put thought into it so that you really understand the formula and you're not just writing stuff down, because obviously that doesn't work. So if you really think about it and try to make that connection and try to see how it works and why it works, then this activity should help you arrive at the distance formula. So really try your best on this one. Collaborate with your group members and discuss ideas and make conclusions. So this would be a great opportunity for you to work together. I know you're watching the video separately, but if you can try and be at the same pace and pause the video together, then maybe you can discuss ideas, and that way you can move forward through this activity. Please write thoughtful and detailed answers to receive credit. Remember, I'm giving you credit based on your answers now, not based on completion. So if you're just writing down what you see on the screen, then I won't give you credit for it. So I really need you to put these ideas into your own words and really think about it so that you can understand the distance formula. The answers must be your own. Again, make sure you're putting thought behind this so that you can understand what we're trying to do here. And this will be assignment number 1 for the week. So please make sure you are trying your best. Okay, so you should have this paper in front of you. Go ahead and fold it in half like a book, and then we'll go through it together, starting with step 1. So for step 1, you'll see this image here that we've become very familiar with over the past couple of weeks. And so what it's asking you to do is to use the image in the space below to show how the Pythagorean theorem works without using any words. So it's almost like your project, but without all the construction. So what I need you to do is pause the video now and using arrows, no words, just formulas and symbols on this diagram, show how the Pythagorean theorem works. So pause the video now. Okay, so hopefully in the previous part you were able to show how it works without using any words. So go ahead and compare with each other, see if you were able to come up with similar things, and hopefully if you were, then that means that you understand the Pythagorean theorem and we could move on to step 2. So step 2, what we're doing is we're taking that right triangle and we're putting it on the coordinate plane. So all I need you to do for this section is to write down what you notice. So take a second, pause the video, write down everything you notice about this image you see in front of you. Okay, so hopefully one of the observations that you made was that this is a right triangle and we're putting it on the coordinate plane. So I know it doesn't have the little symbol here, but since it's on the coordinate plane, that does indeed make a 90-degree angle. So this is a right triangle, which means Pythagorean theorem can be applied. So the first question here is asking, how can you find the distance between point A and point B using their coordinates? So here's A, here's B. Now remember, for Pythagorean, we need the length of the leg. Now, because it's on the coordinate plane, it's easy peasy to just kind of count how long the leg is. So 1, 2, 3, 4, and 5. So I know that that's 5. However, what if we weren't given the image? What if we were just given that the coordinates of A are 1, 2, and the coordinates of B are 1, 7? How would you be able to find the distance between point A and point B? So I need you to go ahead and look at these numbers, stare at them, and see. We know the distance is 5 because we saw that on the coordinate plane. So from these numbers, how can you get them to equal 5? So take a second, write down your thoughts. Don't just write down what I wrote. I need to see your thoughts on here so that I really can see that you're processing this information. So pause the video, write down how you can find the distance between A and B. Okay, so hopefully you arrived at a way to get the distance from A to B without using the coordinate plane or without counting the distance. So now essentially we're doing the same thing, but now we're comparing A to C. So how can you find the distance between points A and C using their coordinates? Describe what you have to do related to the X and Y coordinates. Okay, so A and C. So again, we can count them 1, 2, 3, 4, 5, 6, 7. I know the distance of that leg is 7. So with that being said, if I just gave you coordinates, A is 1, 2, and B is 8, 2, how can you find the distance between A and B without looking at the graph? So if I didn't give you the graph, I didn't give you the image, how could you find the distance from A to B? We know the answer is 7 because we counted them on the coordinate plane. So from these numbers, how can you arrive at 7? And not only that, but what do you notice about the coordinates? So these are the X coordinates, these are the Y coordinates. So what observations can you make about the X coordinates and the Y coordinates? Write all your thoughts down, compare with your group before you move on. Go ahead and pause the video. Now, as you might have guessed, our next step is to figure out the distance between B and C. So B and C. Now for this one, because it's on the coordinate plane, we can't just count the distance because it's not horizontal or vertical. We can't just count the squares nicely. So we have to use what we already know, which is Pythagorean theorem, right? I know that I can find the distance of my hypotenuse if I know the distance of the legs, which we do. We know A is 5 and B is 7. So I can very much take what I know and use the Pythagorean theorem to find the distance of my hypotenuse. So let's go ahead and try that. So I know Pythagorean is A squared plus B squared equals C squared. So if I take these lengths and I substitute them, so 5 squared plus 7 squared is equal to C squared, I get 25 plus 49 equals C squared. Yes, you should be writing this down. Add these together, you get 74 equals C squared. Now remember, I don't want C squared. If you write down C squared and you stop there, you're giving me, if you look back at the image in step 1, you're giving me the whole square. I don't want the whole square. I just want the length of one of the sides because that'll give me the length of the hypotenuse. So what I need to do here is I need a square root. So I know C is approximately to 8.6, okay? So I know that much. However, what if I didn't give you this image and instead I just gave you the coordinates of B and C? Would you be able to arrive at the same distance or length for these two coordinates if I didn't give you the image? So go ahead and finish writing this down. Pause the video if you need to, and then we'll move on to the next part. Okay, so what if I just gave you coordinates B at 1, 7 and C at 8, 2. Now, let's look at what we already know. We know the length of A is 5 and we know the length of B is 7. And I need the two legs in order to find the length of the hypotenuse. So the question is, looking at these numbers, am I able to arrive at 5 and 7 somehow in order to find the lengths of the legs? So stare at these numbers, see how you can manipulate them to get 5 and 7 out of 1, 7, 8, and 2. And then write down your thoughts. Remember, I'm grading you on your thoughts. and see what you arrive at. Compare with your neighbors, talk to your group members, see what you can come up with, because essentially, like I said, what we need for Pythagorean are the lengths. We need 5 and 7. So how can we use the coordinates to arrive at the lengths without having to put this on the coordinate plane? So pause the video here, write down your thoughts. Okay, so hopefully you arrived at some type of subtraction happening. So if we look at B, we know that's 1, 7. We look at C, that's 8, 2. We know A is 5 and B is 7 for the lengths of the legs. So look at this. If I take my x coordinates for both C and B, if I do 8 minus 1, hey, look at that, I get 7. And then if for my y coordinates, if I take 7 minus 2, hey, look at that, I get 5, okay? So the nice thing about this is that if I subtract the x coordinates and I subtract the y coordinates, guess what? I'm able to find the lengths of my legs, and then I'm able to use Pythagorean theorem. So hopefully going through all those observations, you are able to arrive at this conclusion. So just subtract. Subtracting gives us the distance between 2 points. If I subtract these, I'm able to find the lengths of the legs. So go ahead and write down your thoughts here. Write down what I just said in your own words so that it stays in your brain, and that way we can move forward this week with the distance formula. Okay, so here's a bonus question. So what's the distance between points A and B? So the coordinates of A are 8, 8. The coordinates of B are 3, 2. Use what we just learned and see if you can't find the lengths of these legs to then find the hypotenuse. So take a second, see if you can do it, and then compare with your group members before moving on. Pause the video here. Okay, so now I need you to draw some conclusions. So write a rule for finding the distance between two coordinate points using the Pythagorean theorem. So basically summarize what we just did in your own words, your own thoughts here. If you're able to process it in your own way, that means you understood the distance formula. Now, I didn't really give you a formula. I just showed you how to find the distance between 2 points and then use that to plug it into the Pythagorean theorem. What you're doing here is you're putting all of that together. So don't just tell me you subtract. Yes, you subtract to find the lengths of the legs, but then what? So don't forget to include Pythagorean theorem in here, okay? So use as many key vocabulary terms as you can, putting the two ideas together. Pause the video now. Okay, now I need you to finish up these last thoughts here. So this next question, when might someone need to use this formula in real life? So write down your ideas, compare with your neighbors, and then answer the 2 questions at the bottom. So what is one thing that surprised you in this discovery lab? And what is one question you still have about the distance formula? We will go over it again in detail on block day just to make sure you understood it, but please write down your thoughts. The more you write, the better I'm able to help you on block day so that you understand this then if you didn't understand it today. So write down what you need to write down. Remember, this is what I'm grading. Write it down in detail. Write down your thoughts in your own words so that you get your points for the day. So pause the video here. Okay, so before you turn in your work, I need you to check these things. So first, is your name on your paper? If it isn't, go ahead and write it now. Are your answers thoughtful and detailed? So you didn't just write down what you saw on the screen. You actually took the time to write down your thoughts. That's what I'm looking for. That's what I'll be grading. And are your answers your own? So at the end for the conclusion, did you put all your ideas and thoughts together and didn't just copy your neighbor? The point was for you to process your way through the distance formula. So hopefully you were able to do that. Once you're done, please turn it into the sub and then move on to the Edpuzzle on the distance formula that I've attached in Google Classroom, and then work on the extra practice. I hope to see you all on block day. Be good, make good choices, be kind to your teachers and to each other, and be kind to the sub especially. All right, I'll see you all later. Bye.